If you put any number over 9, it makes a repeating decimal. 1 over 9 makes 0.1 repeating, 2 over 9 makes 0.2 repeating, and so on. Let's look at why this is. We want to make this 1 divided by 9, so we can write it like this, and let's make this 1 1.00000. We're going to bring this decimal up here. 9 won't go into 1, so how many times does 9 go into 10? It goes in 1 time. 1 times 9 is 9, and we subtract that, and that gives us 1, and then we bring down a 0, and then we repeat. That gives us another 1, we repeat again, and we'll keep repeating. That will give us 1s going on forever. Same thing happens for 2 ninths, or 3 ninths, or 4 ninths, all the way down to 9 ninths. And that works for all of these when you have a 9 in the denominator. And if the number in the numerator is less than or equal to 9, it's always just that number going on forever. Same thing happens for 99. If a 99 is in the denominator, whatever number's in the numerator, it's a 2-place value version of that number. So 1 would be 0.01 repeating, 7 is 0.07 repeating, 16 would be 0.16 repeating. We can go all the way down to 98 would be 0.98 repeating, and 99 would be 99 repeating. It's also true for 999. So 1 over 999 is 0.001, 15 over 99 is 0.015. We can go further down the list. 996 over 999 is 0.996, and this would be 0.996, 996, 996. It just keeps repeating the 996 over and over and over again. This is true for all of these. Any fraction with only 9s in the denominator will always create a repeating decimal. But it happens to more than just 9s. If we look at these and we look at the factors of these, if any of these factors other than 1 are in a denominator, it will create a repeating decimal. So we'll break these out and we'll include all the factors of 999. All of these will end up being repeating decimals. We already know these 3 are repeating decimals because of what we talked about before, but these other ones will also be. To show an example, we'll just put 2 for n for all of them. So we can multiply all these by a certain version of 1, 3 over 3, or 37 over 37. When we do the multiplication, we get this. 2/3 becomes 6 ninths, 2 11ths becomes 18 over 99. All of them can be changed into a fraction that has only 9s in the denominator, which means all of these will have repeating decimals. These are the repeating decimals for all these. 2 over 37, for example, ends up being 0.054, forever. And that's true for all these. They'll all be repeating decimals. For a fun fact, 77777 is a factor of, I think this is 39s. That means if we put something over 5 sevens, it has to be a repeating decimal. Let's do something like 6050 over 77777. This ends up being equal to this repeating. It actually repeats after this many decimal points. If you want to see the math behind it, if we take this, multiply it by this over this, which is just 1, so it won't change the fraction, the top part ends up being this right here, and the bottom part ends up being this right here. So it ends up being equal to this. So anytime you have anything that's a factor of any number of 9s in the denominator, it creates a repeating decimal. How exciting.